Okay, so good afternoon. I am Anto Budiarjo. Welcome to Monday Live. This is something we do on Monday afternoons, 3 p.m. Eastern, to try and figure out what the future lies for smart buildings. So great to have you with us today on this Thanksgiving week. In case you're wondering who we are, our profiles are listed on .org. And also to point to the press here are personal and not of any company or organization. So please keep that in mind and make this conversation, make this hour more interactive by putting your questions and comments on the Zoom chat. That's always is good for this hour. And if you want any of the slides that's is presented here, it's also available on mondaylab.org. So head over there. So this is November, and this is last Monday in November, and we are focused on how software is eating buildings, which is a play on the whole Mark Andreessen comment actually 12 years ago now, back in 2011 or thereabouts, on how software is eating the world. So this is of that. And so our agenda today, news and chit chat, and then talking about how software is eating buildings. And we're going to be talking about IT/OT convergence, sort of the software edition of that conversation is what we intend to have today on this hour, and then hopefully some interesting discussion. But before we go there, I'm going to hand it over to Ken for an update from Automated Buildings. What's going on, Ken?
Thank you very much, Anto. When I started in the automation industry 50 years ago, I was taught that good automation is indistinguishable from magic. And as I evolved in the world of DDC and internet, cloud, AI, I came to understand the power of new technologies. If we dig into Arthur C. Clarke, who that quote came from, that any sufficient advanced technology is indistinguishable from magic. And he has a few laws that go along with it, which I thought were kind of fun. It said the elderly will tell you what can work, but they'll try and tell you what is going to work. They'll probably be wrong. I'm paraphrasing that. And only by discovering the limits of the possible is it to, let me just move this, click, there we go. When only discovering the limits of the possible is to venture a little way past them into the impossible. Thought that was an interesting comment. Any sufficient advanced technology is indistinguishable from magic. And I think that's actually where we all are right now, is we're in this, the magic kingdom, and it's going to be a lot of fun. So that's a good segue into Orlando. And what we've done there is we've just put a bunch of our screens from the Orlando website, the AHR website. And you can see we're populating the screen again with faces. More and more I'm seeing that the people, it's not the technology, it's the people who embrace the technology and reappear and try the impossible, fail, and reappear with something that is now possible. So I think that's interesting that that's kind of all getting threaded through. And where we thought we were going to be all about technology, in the final analysis, looks like the site is tending to be about the people who heard the technology. And I'm really pleased with that direction we're going. In the middle of our slide, we've got a summary of last Monday's Monday Live. We built on the quote that Rick made about we needed a test bed, like a flight simulator. And then Rick has followed up with a report back from the event he went to in Salt Lake City. So I think you want to read that. So I think that's the quick summary of what's happening at Automated Buildings. Back to you, Anto.
Thank you, Ken. I love that quote from Arthur C. Clarke, as always.
Mm-hmm.
I'd like to add
Uh,
something to that, if I might. Anto, this is Keith.
Go ahead.
Yeah, Ken, it's something that you mentioned, magic. Over the weekend, Lewis Martin, who I'm sure most of you know of, he posted something. Actually, it was a couple of weeks ago, but he posted something about the confusion of what a master system integrator is, an MSI in our industry. And there was talk everywhere from, digital twins to BIMs to, BAS integration only versus enterprise. And yeah, my part of my answer included um, a true MSI displays almost magical mastery in connecting many different types of systems together at the enterprise level. Like, I thought that was kind of funny, I mean, about the magic part.
The wizard.
Yep.
I think I'd give you a few stars as a wizard, Keith. Good job.
Thank you.
Good job.
Thank you.
So MSIs are the wizards of this industry. Okay.
The only thing is the MSIs are in an incredible learning curve because they are walking from traditional into this new world that Rick is describing. So I think it's really interesting to watch them squirm. And I think we need to move from just systems integrators to those that would bear themselves as master systems integrators. And that's got to be a tough title to live up to, but it's a necessary one, I think. And we definitely.
Yeah, and then I included the picture of me last week in a dirty mechanical room at a refrigeration customer of ours, Northgate Markets, polishing off my reverse engineering of a new Danfoss gateway.
But that's what the wizardry is all about, is going from tomb to womb kind of thing, is to just, I guess it goes the other way, womb to tomb.
Yeah.
But anyway, yeah, so I think those that can do that transition of actually making this stuff work is truly the magic.
Okay, so moving on. This is the link board as normal. And before we move on, I think from all of us here, wishing you all happy Thanksgiving this week. I hope you have safe travels if you're traveling, and I hope everything goes well. So have a great week. Have a great Thanksgiving Day. Any other thoughts or news or comments anybody want to bring up before we move on? Hearing nothing, we shall move on then. So how software is eating buildings is our theme. We spent the first week talking about the ingredients of a building dish. As you see, we then moved the following week to talk about what open is all about, protocols, how that's interpreted in software, to open data and accessibility, open software and development, as well as open systems. So those are kind of the areas where software typically becomes open. So that was an interesting conversation. And last week we talked about in what ways open software enables value creation, especially for buildings. That again was an interesting conversation, and I think this is standardization is one of the things that we talked about, and I think that's where the concept of a flight simulator for building, obviously it's not exactly flight simulator, but that was sort of the model that Rick was using as being, how can you tell a computer is a PC compatible back in the 80s? So interesting there. And so today we want to talk about IT/OT convergence from a software perspective. What does that mean? So when we talked about this last week in our planning call, IT/OT convergence, this is obviously not a new topic for this industry, for building automation of smart buildings. Although most of the conversations about this up to now has really been about the IT OT convergence in the network sort of arena. I remember, Mark, I think it was about 3 or 4 years ago, you invited me to a panel in one of the Linkspring events to do with this. So there's been many sessions on many conferences about IT OT convergence, but it's tended to be mostly on the network side of things. But there's a lot more to convergence than just network. So that's kind of what we talked about in the planning call, and that's what we want to talk about today. And I had the homework to go and sort of map this out. So this is what I did. So the way I kind of looked at this was that there's really sort of 4 different areas that we can think about IT OT convergence. The first is the infrastructure. This is where connectivity and networking comes in, but also we have to think about cloud here and standardization and interoperability. That's all sort of infrastructure related stuff. Then we can look at convergence from a data and analytics perspective, where we talk about data integration, AI, ML, and energy management related stuff. We can also talk about IT convergence from a perspective of control and security. Here we have things, issues like automation and control and security, how those come into play in the convergence sort of space and what that's all about. And lastly, the sort of the experience and the sustainability of everything. So these are kind of the big areas, but they are big areas. And what I did I did a little bit more research and sort of started to sort of dig in to what does this actually mean. So in the infrastructure space, really what this list is all about is that when you think about connectivity and networking, the focus in the IT side of things has always been IP networks. All networks in IT is IP, has been for a few decades now, right? So this is kind of the IT focus in that convergence. The OT side of things has been historically proprietary and isolated. That's what the networks are typically, right? So this has really been the sort of the debate on the convergence of IT and OT has been between these two. And in many ways, we've sort of rationalized it as being what we end up having when you combine these two is a unified IT network, working with OT protocols wherever it needs to enable real-time IP-based networking and control. So that's kind of what the common architecture of this industry is kind of like that, or described similar to that. When we come to cloud and edge computing, the IT focus is always on the centralized and storage and processing of big things, right? That's why you have billion-dollar data centers and things. But when we talk about OT, the focus on cloud and edge and computing tends to be sort of low latency. The issues are we need to have low latency, we need to have reliability in terms of storage and processing, right? In other words, local. So what we end up when we converge that is we end up with the edge handling real-time OT data locally, and the cloud manages analytics, mass storage, and updates, right? Combined as what we these days call as cloud native. So basically, that's an IBB described right there, right? So that's the convergence from a cloud and AT computing. From a standardization and interoperability perspective, IT has obviously been about the IP protocols, HTTP and others, and the OT has been on the other types of standards. And so what we're sort of talking about in the convergence of all of that is how do we create a sort of a different kind of standards for cross-domain interoperability between these domain standards, but do that using IT protocols. That's really what's going on here, is we're bridging the different domains that exist in buildings in OT using IT-based issues. That's really what we've ended up with. So this is kind of an interesting table. Then we get into data analytics, where in IT is all about mass processing, and that's really what they're all about. Again, big data centers and things. And the OT has been much more focused on the real-time systems and sensors and actuators, really sort of making that, integrating them and sort of analyzing them. And so what we've ended up with is IT-centric, doing IT-type analyzing of OT data is basically what we've ended up with. And if you think about the analytics companies and what Jim is doing is basically this, is using IT kind of methodologies to analyze and integrate the OT stuff. And on AI and ML, IT focus has been to develop the models, mostly for humans. Our focus has been to using those models and providing the data for training and deployment to actually make it work. So again, we can sort of combine the two things to actually get AI-driven insights based on stuff that's in the buildings. On energy management, IT is really more focused on the visualization and the reporting of energy issues, whereas IT is actually directly controlling the energy systems, right? So when you combine it, you have advanced systems for demand response and predictive maintenance and kind of stuff like that. So you can start to see the pattern here. In control and security is kind of a little bit different again. In the IT, automation is really automating the mass infrastructure of data centers. If you think about, what happens this coming Friday with Black Friday, and a whole bunch of Amazon servers get automatically sort of put into play. All of that is what IT does. We do different things. We do things like local events and control sequences. So again, this can be converged. This is being converged. In control, IT is really more focused on controlling users and resources, whereas we are more concerned with controlling information from sensors and and logic to make things work. And again, there's a sort of a converged view of that. And in cybersecurity, IT's focuses on firewalls and stuff, the sort of the human side of cyber, and OT were more about protecting the physical networks and the devices. So you end up converging into a holistic picture. And lastly, the experience. IT is obviously all about, the IT world is about the experience of apps and platforms and dashboards, whereas the OT focus is more about the tools for engineers, and really OT is not very focused on user experience for the actual end users, because there isn't much other than an occasional thermostats and set points and things. So it's not much here, but if you converge it, you start to get the benefits of both worlds being able to be combined. In terms of user interfaces, it's all HTML for IT people, and OT is kind of some HTML, a bit of proprietary UI, and some Linux command line interfaces. It's kind of norm. And so you can see a converged world where HTML pages from cloud and local servers can be combined and can be integrated in some sort of cloud-based platform. Yeah. So, and sustainability, that's pretty sort of straightforward. It's not really in line with actual technical functionality things. So, in all of these different areas, when you think about IT-OT convergence, it's really software that's doing all of this stuff. And it's not surprising, because software does pretty much everything. And sort of the way I think about it, this is really how software is eating buildings, because it's actually getting all of these types of applications and all of these kinds of interactivity, both in the IT side and the OT side of things. So convergence is really being driven by software, especially open software. It's kind of the position that I think this shows us. I'd love to open it up to the group and thoughts.
Yeah. So, Otto, I applaud your efforts here. I think the way you laid it out is really very workable and very understandable. And I almost view it as another version of the smarter stack, but more describing to more taking on, if you will, the challenge of convergence between IT and OT, right? And because it effectively created a new stack here, and then created drill downs for each of the areas to describe that of what's going on between the two groups. So just for everybody on the call, we talked about this conceptually on Wednesday. We're now seeing it for the first time here today, just like you are. And I think it deserves, I think I applaud, again, I applaud you for the effort you made to put this together. And I think it deserves some really good feedback and, potential revisions or just work to build on it, because I think it's really terrific.
Thank you.
Yeah.
I'm interested sort of in a before and after, once again, in the construction process versus operations. And what I don't see here is the connecting of the two things in terms of building information modeling and industry foundation classes, and how the data from the building part and the software associated with new construction translates through to the operating side.
Yeah, that was not the focus, obviously, of what I was trying to break apart.
Right. No, but I'm just trying to make the point that I think there's a convergent story there as well.
That's true.
Between a lot of the data that goes into creating the building and making that data available on the operating side, I think is an important, powerful piece of the convergence.
Yeah, but
Good point.
that's not ITOT. It's a different
That's
kind
true.
of convergence, but you're absolutely right.
That's true.
Where do you see the digital twin fitting in this? Do you see much of this happening inside of the digital twin and then decisions being pushed back to the building? Or do you see it as data flowing back and forth between? Like what profile? Would the digital twin appear in all of these blocks?
Well, I think the way to try and look at it is that if all of these things are implemented, then one manifestation of that would be a digital twin that's actually being a twin of a building. It sort of almost requires all of these things, because it requires certainly all the infrastructure, it requires the analytics. It would be best with AI and ML, and obviously there's energy management in it. So I think this makes up a digital twin. But then again, I could say this also makes up other things. If you recall, if I go back sort of rapidly to go to this is the ingredients. This is our first week. Right, so in a way, that big list of the convergence is really it enables much of that. It enables the subscription model. It enables the digital twin. It basically creates a system of systems. It's best if it's all open source, or you get a lot of leverage when it is. And there's obviously AI and ML and the other things. So the two are not. I don't think that picture is actually of a digital twin, but it actually enables it. The abstracts don't exactly align with each other.
A few weeks back, we chitter chattered about the digital twin becoming the enabler, and that kind of grabbed my imagination. I'd always seen it as a digital twin and something you tested, but what we started to see is that some people envision this, that all of the interaction will occur in the twin, and then the twin will feed the building. Which I found that was a little bit of mind shift for me, and maybe everybody else saw it pretty clearly that way, but I hadn't seen the twin becoming so powerful. And it actually makes sense because it becomes completely a virtual model, that things can be changed and not break things. And you can always do some checks and balances before you actually send that information. But rather than dealing with the building and some of this stuff, we might be dealing directly with the twin. So that was just a bit of a eye opener for me. I don't know what everybody else feels.
So is it safe, would you say it's safe to say that a digital twin already is, for all intents and purposes, an IT product? Right? I mean, it's built in an IT infrastructure. It's generally, I guess it's an application that can run in a dedicated server, but most cases it's running in a cloud server. It's written in software that's used for IT applications, and integrates with IT resources, say coming from a CAD package, as an example. So it already is in the IT world, but the goal here, if I understand correctly how digital twin is trying to go, is trying to make that leap to where it can cross over, and grab OT data, right? So that the two can join, which is exactly what we're talking about here in the convergence. But up to now, it's lived in one domain, the IT domain. Anybody disagree with that?
So you're sort of saying that the twin is the IT side of things and the physical is the OT side of things.
Exactly. I don't know of any. I don't know of a digital twin that unless that was developed on the assumption that it would have real-time data plugged into it. Now, maybe current versions they're trying to bring that into the picture, but all of the development, all the software development is being done on the IT side.
Mhm.
And they're wanting to converge, and some are doing some first generation convergence the hard way. And what we're saying is, look, we got to address this thing holistically and address all of the areas that you're talking about here, the infrastructure, the analytics, the control and security, the UI experience. All that has to be done holistically if something like digital twin is going to be ultimately successful, in its vision for the two bidirectional operations, Ken, that you're referring to.
And that obviously brings in Jim's point about the life cycle side of things as well.
Right. Yeah, exactly.
So really everything you've introduced so far this morning would live inside the twin.
I think it makes the twin.
Wait, can you repeat that? It makes twins?
It makes the twin. All of this makes the twin. It's the way
They are components of the twin,
the things that
go into making a
Yeah.
digital twin.
It would be
And it can-
loaded into the twin first before it'd be loaded into the building, I guess is my point.
No,
And then the magic happens and it becomes indistinguishable. And that's where I think when you open it by starting with the new technology becomes indistinguishable from magic, the digital twin of a Rivian is actually controlling the Rivian. The digital twin isn't something that it is used to imagine what the Rivian vehicle could do, but the same stack is also then being used to actually drive the Rivian. So in the gaming engines that are being moved from my 13-year-old's gaming system to actually driving tractors and running real things, that's where the magic starts to get blurry. So not to confuse everything, but the digital twin, the intent of the digital twin is not for it to be some separate animal sitting in the side critiquing how well you're driving. It's actually intended to be augmenting the act of doing. And there are examples of where that's already crossing over, and I just mentioned a couple of them. And it was actually interesting in Salt Lake City just a couple of weeks ago to see one of the larger Kubernetes platforms, SUSE, demonstrating all of the impact it has in working with Rivian. So they literally had a Rivian truck on the show floor, and we're pointing out all the places where IT is working with AT, automotive tech.
So maybe because many of these things like digital twins are kind of concepts and quite abstract concepts, it's difficult to fit it exactly neatly into each other. Or is that not helpful?
I remember a while back, I explained that my background originally came from simulation, computer simulations back in the old days. That was the best we had. And that's what we were attempting to do, was to build a twin. And, so I think now we have the capabilities of doing that and coming up with a twin that is a much closer reality than we were able to in the old days. So yeah, the idea of the twin and the reality merging, I think, is definitely happening.
And how does that help us with smarter buildings? I mean, I kind of feel that that's what we need for buildings to be smarter, but can we dig into that?
I think the concept of a digital twin needs to be defined a little better amongst us to say whether or not this is or is not one. When I think of a true digital twin, I think of Rolls-Royce or GE having a computer simulation of the plane engines that are tracking the planes as they're flying, getting the real-time data from the planes as they're flying, and tracking that performance against a model of how it should be performing. And that type of real-time data, there's obviously a value in it for both the airlines themselves, as well as the engine manufacturers and the plane manufacturers, to invest in that type of real-time understanding and monitoring and management. Because if that plane lands and it can't take off again, it throws off all sorts of other things. So there's a follow-on effect to it not performing to standards. And so when we typically talk about a digital twin of a real estate asset, most building systems do not have. So Mike says a digital twin doesn't not have to be that complex. You're right, Mike, it doesn't have to be that complex, but where I was going is we can't get to that level of complexity right now because most buildings don't have the instrumentation and the sensors to achieve that. There are a lot of comments coming through, but what I'm trying to get to is that really, just like the not having the data from the actual building systems to know how the building's actually performing with the right temperature sensors, CO2 sensors, oxygen sensors, airflow sensors, etc. Same thing with water. We basically are, there's a lot of opportunity because the same lack of data and information is also on the financial side of the building operations and the status of the actual physical building assets themselves. So I think we're a long, long way from being able to realize a complex digital twin. And I think calling it a digital twin, there is an element of value in it where you're helping people who aren't familiar with the building understand where things are located in the building in 3 dimensions. But to get back to the IT OT convergence, we really need to have better data and more organized data, and open data will enable all of this to be realized more effectively in the future.
An example that just flips into mind for me is the Formula One race cars that are heavily instrumented and basically controlled from the pits. And if they lose oil pressure, they shut them down. Whether they're going to lose the race or anything, just to save the car rather than blowing an engine. And they know that engine's going to blow minutes before it's going to blow. And I think that's to me is a closely coupled digital twin.
But it isn't these sort of issues that we've been talking about, all of these, is really about bringing the IT and OT worlds closer together to get closer to that holistic view, right? That's really all of IT OT convergence is all about.
I think that there needs to be a basic foundational level of compatibility between those two types of platforms, right? I mean, if you even think literally about how software is eating buildings, well, it's consuming data, right? That's the idea. If we can get the data to move between domains equally and easily and equally, then that's the convergence that we're talking about and looking for. I don't, there are certainly ways, architectures, and so forth that one could architect a system that would represent a highly converged system that would live in both of these worlds, both of these domains, if you're starting from scratch. But at the same time, you know, we've got the current built environment out there, and we should be applying what we're talking about and thinking about to what already exists. And in those cases, I don't think owners, users care physically how they go together or what protocols are used or anything. It's all about being able to consume or equally and easily move data back and forth, right? So if that's through a digital twin or, you know, any other application, I think it doesn't matter, right? We're talking about the same thing. I'm just trying to grasp this at a very practical level here.
Actually, it's EIO, eating I, eating O. They're both eating each other. They're melding together,
Yeah,
becoming
is.
homogeneous.
It is. I mean, if we went through a series of 10 buildings and came up with a strategy on how to converge each of those buildings, every strategy right now would be a little bit different based on what the existing architectures were and what the use cases or applications desired by the owners were, right? We would build that a little bit differently. In the part that we're trying to get to, whether it be IBB or Div 25 or whatever it might be, are the stepping stones on the path to making that share, that ubiquitous domain, if you will, easier.
Yeah, and trying to think of a simple way to describe when we talk about software eating the buildings. We talk about all the difficulty of all the different systems and all the different device types, and then the data associated with the device types. You know, again, my simple brain, it's like it's a heck of a lot easier to teach the software to deal with the different types of systems than it is to change out all the systems. I think that's one of the things I'm hearing, is that we're not going to change out all the different systems overnight. We got to deal with the legacy protocols and the legacy networks and legacy everything. But if we can, at the software level, teach the software to deal with that, bingo. And that's what I think that's what we're saying, is like the normalization is not, we're not going to teach BACnet to understand whatever. We're not going to teach the protocols to understand each other.
No, they are what they are.
They
right?
are what they are, and they are out there. And similarly to the IFCs and the world BIM or the world GIS, we're not going to teach those data packets and all that stored information. We're not going to teach it to change its stripes. But at the software level, we can teach the software to understand the data and the systems as they are. And that's why we're saying the software is eating the buildings. Teaching data to change, pretty difficult. Moving all the data to a common place, crazy expensive. But teaching the software to understand the unique attributes of the different systems is what that, and by the way, that's what's happening in every other domain on the planet right now, is all the incompatible systems are being dealt with by teaching the software to interpret the systems that are around it. And greatly simplifying, but that's what we're talking about, is like the focus has always been, oh my God, we got to normalize all these different packets at the wire. And it's like, or use the power of processors and the evolution of software to go ahead and just learn how to interpret the different systems as they are.
Maybe I can lighten it up a little bit with Old MacDonald's Farm, E-I-E-I-O.
Thank you, Ken.
Or was that Animal Farm? Sorry.
Yeah, so I mean, that makes total sense for the software to be the thing that can do the mapping or the aggregating or the translation, because it other than the software, it's going to be humans. It's either we do it, we interpret it, in which case we're interpreting a big mess. We can't do it. We're not clever enough. Or we create software which are basically agents of us to do specific things. Sorry, Tracy.
No, you're fine. You're absolutely confirming what I was trying to say, I think, or what I was thinking. In that, I mean, software is the only flexible portion of an automated system once it's installed, right? Hardware goes in, parts go in, sensors go in, they're there unless you want to change them. So your only option to make that adaptable at this point is through software and moving that software about in whatever way that you possibly can. And I think, and that's plumbing, right? I mean, when you plumb a house, if you had only had sinks, you'd have a certain amount of plumbing, but if you introduce toilets and wastewater, that's a whole other kind of plumbing, right? So we're trying to facilitate some kind of a standard in a universal plumbing platform, if you will, that will allow us to adapt to whatever use of that data that we would want. either being consumed or pushing back into the building in this whole thing.
So Tracy, to build on that, I agree completely. And just to remind everybody, from sessions previous to today, the IBB includes the concept of connection profiles as the mechanism we're proposing to be that means by which these disparate applications can easily share information from one to another. And because that concept of a connection profile doesn't exist necessarily in either the IT or the OT world today. And so we have a mechanism, and that's being developed and is being shown as a way to solve this problem.
There's another realization that just occurred to me, that software has been around for quite a while, and obviously all DDC controllers have software.
Mm-hmm.
But in many ways, the way that those software lines of code were created 10, 20, 30, 40 years ago is completely different to the way this software is being created today, the sort of the cloud native, the open software. So we couldn't expect the software that was running in DDCs to do this kind of thing at all, because all it was doing, it was just running that DDC, and it's running the sequence of operation. It does that over and over again, and that's all it does. Whereas the sort of software that we're starting to see now, especially in the cloud native front, is software that's generic, that can be moved around, that can do many, many different things very, very easily. So that's another difference in software. Software itself has changed in the past decades. How does that play into that?
Yeah, I was thinking the same thing when you first started talking about it. The evolution of software and its capability is really the key difference here. That's making most of what we're talking about, the vision of what we're talking about, possible, right? Initially, software used to be used primarily for doing things that were repetitive, very fast, right? Over and over and over again. Not a lot of adaptability associated with that, not a lot of thinking or outside the box. And then, of course, as programming as a science evolved, that changed more and more and more and more, to the point now where, AI has the ability to, think for itself, if you will. So it really opens up a whole new set of use cases and capabilities that we never had before. All we got to do is figure out how to get the data available to be exposed to the resources necessary to consume it, right?
And more often than not, the data is actually available. It's just not in the right format. So this, again, back in the day when software first started coming about, right? Software was really dependent on the data type and the data access. So the software could only do what the data would allow. So remember back in the day when like a Lotus 123 or VisiCalc was, had a specific file type that it could use. The question would be, what came first, the file type or the application type, the software type? And they were very closely linked, the application and the file type or the data type, very dependent on each other. And what, Tracy, you're describing now is like, you can drop a picture into AI, and that photo gets transformed to be used by a processor, by a software application in a way that resembles magic. And that's where software is now, is you can drop a blob, big or binary large object. Is that what blob stands for? You can drop a blob into an AI engine, and it'll extract, transform, transmit, and load into a binary processor, binaries, software binaries, and then crank out an output that also looks like a graphic or a text. And so the evolution of software has been extreme in the last few,
Yeah.
decades.
Okay, but all software in the past was controlled by the hardware it lived in. And every time we got more powerful chips, I mean, I came all the way from, the early things, we had no power to run anything, and we had to work in binary to make stuff work. And then the languages always moved out. So software has been always contained by the hardware. But now as we decouple them and move into cloud native,
We've definitely hit a tipping point. When you said that, Ken, it reminded me when I worked at Intel, there was always this conversation about who's ahead right now. Is it hardware or is it the OS, the software part of it, right? Is the OS too big for the processors and the systems, and therefore the computers, that's causing it to slow down? Or is the hardware ahead, and now there's room for the OS to evolve and get bigger and include more things, right? And to me, it feels like in this world, we've hit a tipping point where, software is no longer resource limited. Now it's just imagination.
Because the software have become sort of pieces that you can use, which you can combine to do complex things. How does that come into it?
And that's the imagination piece of this
Right.
whole thing, I think, right?
Yeah, because a piece of software may, effectively add two numbers, right? And that piece of software can be utilized in the financial transaction world and energy automation or any of the stuff that we deal with. I know adding up two numbers is a very trivial example, but if you take something that's more complex, the fact that software can be moved around and used for different things was also something that didn't exist 20, 30 years ago with DDCs, because it was only built for that thing, for that purpose and that hardware. It can't do anything else. That's gone.
Yeah.
Now Rick can, and look at a presentation of some a bank doing something at KubeCon, right? And it's actually relevant to him in buildings, or some parts of it could be relevant. That was never the case. Is that the sort of the core thing that sort of made Mark Andreessen say that it's going to eat the world? Because it's basically a piece of software is neutral to what it actually does. It depends on how it's applied, how somebody uses it.
the new software has no boundaries, no
No
restrictions.
governors anymore.
Yeah, there's nothing. We don't have, we're not short of, even if we need more computing power in the cloud, we can reach out for a supercomputer and get one.
Now,
the
I
calc- come
will
back.
say there was another consistent theme out in Salt Lake, and it was everybody whining about the restricted amount of GPUs that are available. They actually talked more about the constrained environment of computing than I'd ever heard people whine about in maybe 10 or 15 years. Now that should say something about where people's imaginations are going with, to Tracy's point, is the operating system the problem? Is the processing the problem? Is the software is the code, is the IO the problem? But there was a ton of whining about the lack of computing resources. I thought I'd throw that in because it was kind of fun.
That's interesting. So that tells me that the cart has tipped and there's been an exponential leap forward on the software side of things that hardware isn't keeping up with, right now. If the community who is out on the leading edge of this is feeling constrained by hardware, GPUs, then that just goes to show you how far software has come on this whole thing.
Exactly. And the imaginations of the 29,000 people that are there are being restricted. So they're having to be creative. God, does this sound familiar? Having to be creative about how you implement software because of the limitations of the communications and the processing.
Sounds like
Go
code
to work with a Z80.
Yeah.
Yeah, Roger just made a point about, is making a point about Project Haystack and the thing called Zeto, which is a validation tool. But the structure of data is very important. We talked about that, I think, in the second week this month, where we were talking about, it was actually part of this conversation here, that this yellow bulleted point was not on this slide in that second week, and somebody brought it up as being missing, and so was this one. So yeah, the need for data standards that is open, which is, I guess, how much did you hear about open data standards in Salt Lake, if at all?
Oh, a ton. And but again, what comes first? The data standard or the software that can dictate what data should look like? If your data wants to participate in this ecosystem of processing and software, you better make the data look like X. So there's again, chicken or egg kind of, oh gosh, I'd like my data sets and my workloads to be able to take advantage of these advances. So I'm going to craft or transform my workloads, my data, to be compatible with the software. But there was a ton of talk about that. And if we have confidence that the software is going to be moving ahead faster, then we can start to dictate how the data is structured, or transformed.
Yeah, and the point that Roger's making is that you need these structures, standardized structures, especially when you want to feed this data into AI. So what have we learned here? Steve, you kind of was the initial motivation for talking about IT-OT convergence. Did we get somewhere where that was useful?
I think so, very much so, in terms of better understanding the challenge and really showing, like I said earlier, as a holistic problem to solve. And I think we've got now, if you will, a new framework in which to better describe what the challenges are. And as we continue to develop the IBB, we can basically test ourselves to make sure we're doing it in conjunction with this, I'll call it this IT-OT convergence framework that you've outlined. So yeah, I'm really pleased with the progress we've made here, and we had some really good dialogue on the other side. We brought in other elements, whether it's the digital twin or the Zeto or the continued evolution of software itself. Because when the software is not, as much as there is still some work being done to improve the way we automate a process in a building, the application, the algorithms, if you will, relative to the evolution of software in areas like AI, it's totally different realm, and it just makes in my mind, it makes it all the more important that we overcome the challenges, if you will, that are making the convergence difficult. That's why the focus on this, I think, is so important, and to define it in the way that we now are doing means we can have some confidence that if we address each of these areas and do it well, we'll solve the problem.
Okay, so I think with that, we're gonna wrap this week's call and this month. So thank you very much, everyone, for being here throughout the month and all of the ideas this week. We will be back next week for 2 or 3 more weeks in December as we start to wrap up 2024. But before next week, we have Thanksgiving. So I hope you all enjoy Thanksgiving wherever you're going to be, and safe travels if you're traveling.
Okay.
Happy Thanksgiving, everyone.
Thanks, everyone.
Bye.
Yep.
Right.
See ya.
Bye all.
Bye.